Good morning, students. Thank you for giving support for my first video, in which there was a good response, and some people have given feedback that the lighting is little bit dim. So in this video I have improved it. So I hope you will find it very useful. Okay, let's take the subject forward. So in the last class we reviewed we discussed what is meant by coordinate geometry and coordinate plane or coordinate axis, etc. Coordinate is nothing but a point, and the location of point is given in terms of coordinates, and that is given with reference to two axes x and y axis. And we also saw that okay. So we discussed that coordinate geometry is nothing but study of geometrical figures with reference to their coordinates. Okay. So as we seen, triangle has got three vertices, and with respect to this, by using the coordinates of 3 points, we study their properties: area, perimeter, and whether the triangle is a right angle triangle, whether it's a right isosceles triangle or a equilateral triangle. So these are the properties. Suppose if you take rectangle has got opposite sides are equal, okay, and the diagonals are also equal, and the diagonals bisect each other. So let us say this is a rectangle, and the diagonals, the length of the diagonals are equal, and they bisect each other. That means this diagonal bisected this one. That means if the length is x1, this also x. If the length is a, and this also a. So by using the coordinates of ABCD, we can say whether this figure, geometric figure, is a rectangle or square or rhombus. Suppose if AB is equal to BC is equal to CD is equal to DA. That means all the sides are equal, then it is a square. But what is AB? The AB is the length, A and B. That we are going to see the distance formula. So if this is one coordinate and this is another coordinate, we can find the distance between the two coordinates. That gives the length, and that is nothing but the sides of the rectangle. So by calculating the lengths of the geometrical figure, we can conclude that this particular geometric figure is a square or rectangle or rhombus, whatever it is. Now we will go further, and we will review some basic concepts involved in the coordinate geometry, right? So we will see some concepts which you have already studied in the lower classes. So one is other one is distance formula. these are all the basic concepts which you must know very well before going further, right? So these concepts, some of the concepts are all of the concepts you might have studied in 9th standard. If not, we will review those concepts, right? First, let us take midpoint between two coordinates, or let us take the distance between two coordinates first, because once you know the distance, midpoint between two coordinates, you can understand easily. The first concept involved in coordinate geometry is distance between two coordinates. Okay, so suppose, and this is x and y axis, this is y, x. For time being, we will discuss only the positive x and positive y, because there are two more axes, that is minus x. If the x extends in the left hand side, it's a minus, because this is a 0 point origin. We call origin. Here it 1, 2, 3, 4. It's a positive number. Similarly, here it is minus 1, minus 2, etc. Similarly, this is minus y axis. For time being, we will concentrate only in the positive x and y coordinates, right? Let us say this is a point A having coordinate x1, y1, and let us say this is a point B having coordinate x2, y2. Now I am connecting these 2 points, and this is the line segment connecting these 2 points, and the length of AB is nothing but the distance between AB, right? Now how to find the distance between AB or the length AB? Okay, now just you draw vertical lines from A and B to the x axis. And what is this point? This point is x1, x coordinate, because this is nothing but x value and y value. This is the point representing x and y coordinate. So this point on the on the Cartesian plane, this is called Cartesian plane or Cartesian coordinate. It is represented by two information. One is how much it is from the origin on x axis. Similarly, how much it is on the y axis from the origin. Okay, so if there is no y, if it lies on the x axis, the point will be here only. But x, it is x1 on the x axis, the value x1, it has got a y value also. That is why it is in the it is at this point. Similarly, this point is represented by x2. This value is nothing but x2. Okay. Similarly, this value is y2. This is how the coordinates are represented. Now we have to find the distance between A and B. Just draw this y1, you extend it. Okay, and this point also. This, what is the coordinate of this point? Because the value is x2 and y value is y1. X value is x2, y value is, so x2 comma y1. This is the coordinate, right? Now we can just put some alphabets A, B, C, and this is D, and this point is E, and this is F and G. Okay, just for our calculation purpose. Okay, now what is this? What kind of triangle is this? It's a right angle triangle. So to calculate the length of AB, we can use Pythagoras theorem. That is nothing but this square is equal to the sum of this square plus this square, right? That is AB square is equal to AC square plus BC square. This is what Pythagoras theorem states. Now AB is the length which we require to find. So AB is equal to, now let us put square for time being. What is AC square? AC square is nothing but AC square. What is AC? AC is the distance between A and C. Okay, this is the length. How to find? Because the Y, now AC is parallel to DE or ED. Okay. Length of AC is also equal to ED. What is ED? The length of ED. ED is, that is, both the points are on the x-axis. So from here to here it is x2. The length is x2. For example, take a number line 0, 1, 2, 3, 4, 5. Okay, 6 and 7. Let us say we have to find the length of QR. Let us take this P. This is also not required. Now take a number line. Now take a number line like this. Number line is 1, 2, 3, 4, 5, 6. We have already studied. Starts from 0. What is meant by 2? 2 is from here it is 2 units. 3 means from here it is 3 units length. These are all lengths from the origin. The numbers are representing. Now we have to find the length between Q and R. Let us mark. This is, we know our number line, this is 2 and this is 6. But what is the length? From here to here, the length is 1 unit, 2 units, 3 units, 4 units. 4 units length. That is 6 minus 2 is 4. How? From here it is 6 units. The total length is 6. From there just you subtract 2 units. This much length. You will get this much length. Because this length plus this length is nothing but 6. In the same fashion, this is the point of C. C and D are on the same x coordinate. Right? So to find AC, if we find ED, then this length is nothing but AC. Now how to find the length of E and D? This is nothing but x2 minus x1. This is the length between E and D, and this is same as AC, x2 minus x1. Right? Similarly, this point, what is the y coordinate? Y2, and this is y1. So the distance is y2 minus y1. From here to here it is y, this length, and from here to here it is y1. So y2 minus y1 gives the length of BC. Now let us substitute here. AB is equal to AC square. AC is x2 minus x1 the whole square. Similarly BC is y2 minus y1. Y coordinate here, y coordinate. So y2, from here it is y2. How it is y2? Because this is nothing but the point B and G are at the same y level, same level. Similarly C and F are in the same level. So from here to here, G, OG, if we call this OG is nothing but DB, and OF is nothing but CD. So just OG minus OF is nothing but BD minus BC. So that gives BC. Y2 minus Y1 the whole square. So AB square is this. So what is AB? Take square root on both sides. You will get x2 minus x1 the whole square plus y2 minus y1 the whole square. So I have told you little briefly because you have already learned. Just to recollect how we derive the formula for finding distance between two coordinates. This is how we derive it.